Okay, hearing none. Let's move on then. I just want to show something really quick. We're almost out of time, but let me close this down and open up. Hold on, I gotta find it. Give me 1 second. Found it.
I would say that once you figure out how to create export your map correctly, it's way easier on QGIS than it is on ArcMap.
Once you know the steps, yeah. Great.
If you guys want to stay after, if people have time, I can show people how to do it really quickly. It's really efficient.
Cool.
That'd be nice. Thanks, John.
Yeah, I was actually going to offer the same thing.
Okay, great. Okay, so we worked on the Seattle Fault, and I just wanted to show a couple images of it, a couple trench logs. There have been a lot of questions about trenching, and we're not really focused on subsurface with this, but it's just kind of like how the mapping gets used to develop the history of earthquakes along certain faults, and the mapping is kind of where we start. So, you know, Seattle was one of the first places to have LiDAR. It got named the Toe Jam Hill Fault, which is actually a back thrust to the main Seattle Fault. So these maps over here show Seattle, and the Seattle Fault has a bunch of different strands going across Puget Sound. So downtown Seattle is right here. So the fault system actually goes right through the baseball stadium, if you've ever been to Seattle on the south side of town. And this little red box shows where you guys did your mapping. And here's a little cross section showing the sort of folded sediments in the Seattle Basin and how the fault comes up and disrupts it. So even though the Toe Jam Hill Fault, knowing the history of it doesn't necessarily mean, you know, there may have been earthquakes on other strands, but they're all active. But it's sort of a proxy for the Seattle Fault Zone in general of when earthquakes happen. Let's see. I gotta click here. Oops, sorry. It's always a challenge here with my small computer and moving your faces around. Okay. So this is where you guys mapped, and just to highlight again, you know, Bainbridge Island's covered with trees, and we have this LiDAR, and we discussed about the landforms, these glacial drumlins from ice moving north-south across this area, and this nice scarp going across here, and we all mapped that. I just wanted to highlight, we talked about morpho mapping on some of the previous projects, and this is before we really had ArcGIS and all this stuff. This is a tracing paper overlay of this LiDAR that was done by myself and a friend of mine years ago, but we do the same sort of thing. We mapped in the streams. I'll show a blow up of it in a second. This is just scaled for the size of this, but we mapped the streams, we mapped drumlins, we mapped little landslides, we mapped scarps and all this stuff, right? This is just sitting around the campfire or sitting around the hotel room at night when we're working here, trying to figure out what's going on, okay? Here's a blow up of that, and it's really, you know, just to show that you can really learn a lot from the morpho mapping, okay? And really, the LiDAR was really helping us, but the morpho mapping was really also helping us kind of understand the topography and try to figure out where to put trenches. So this is the map that came out of it, which is really similar to what all of you all mapped, showing, you know, a few strands and a pretty continuous strand through here. And I'm just going to show, so these are trenches marked on here. I'm going to show a few blow-ups of this to show where the, you know, how the topography was used to, and the mapping was used to figure out where some of these trenches are. So the first one is Crane Lake. We talked about in class, like what this gray area of flat sort of topography was, and we discussed how we thought it might be a lake. There's a stream coming out of it, and it actually is a lake that's ponded on this south-facing scarp. It's actually a pretty big scarp here, and here's the footprint of the trench in this little green arrow. And this is in a paper by Nelson et al., 2003, on the Toe Jam Hill Fault, and also a poster that you can download at this link here. I'll send this presentation to Chelsea so she can put it up in the reverse faults section of the class website too. But what's interesting here is this kind of peach color is all bedrock, and it's really fractured to hell. And these are glacial deposits here on this side, and a really steep scarp from the most recent earthquake, but just shows that the reverse faults can be pretty steep when they get to the surface. And this is bedrock that's been thrust out over these glacial sediments. And there's 5 trenches. Anyway, Nelson did a kind of retro deformation diagram going through time, trying to see how these deposits deform through time, going 1, 2, 3, 4 time slices. By dating some of the deposits and knowing when the glaciation was there, they estimate 3 or 4 earthquakes in the last 2,500 years or so, with the most recent one being sometime around 8,900, which kind of correlates pretty close with when marine terraces were uplifted around the outside of Bainbridge Island as well. And I don't have all the numbers exactly straight in my head because this was a long time ago that I was working on this. But anyway, and then I'll just quickly show a couple of the other ones. So this is the Saddle Trench, which is here again in so here's a north-south trending kind of bedrock scoured feature with a little saddle in between it. That's how it got its name. But that saddle is actually the northern side has been uplifted a bit. And this other one, there's just some subtleties in the LiDAR coming across here, not quite as well expressed as it is in the bedrock here, but there's another feature there. So similarly, again, this is one of the most amazing trenches I've ever seen, actually. Not this one, the next one, but they were all pretty awesome. But you can see this orange layer is thrust out over itself. And again, the bedrock is thrust out over quaternary deposits. This next one is Bear's Lair, a fissure. So we talked about kind of normal faults and also the opening of fissures in the crest of folds. And we don't even see the fault in here, the main fault, but there's indication of folding of the sediments across where we have it queried, where it might be, okay? This is the one that I remember as being the most incredible one, because this brown layer right here is soil. It's a forest A horizon with trees, trunks, and things in it, tons of charcoal, and bedrock is completely thrust out over the top of it. So this is the Mossy Lane Trench right here in the upper left image. Again, it's kind of like a topographic swale that's up on the north. And then the final one is Blacktail, which I'll show in a second. But anyway, so we cited the trenches based on the mapping and where these things were in the forest from what we could see in the LiDAR, okay? And so again, some folding here of faults probably down below. This is the Blacktail Trench. But so they all consistently show up on the north and folding above a reverse fault, okay? And then the last thing I'll show is just a couple field photographs so you can see what it's like there. Here's the forest. Walking around the forest, you're not going to see a whole lot, but this sort of yellowish color is the bedrock. This is the Crane Lake Trench, and the whitish colors down below here are the glacial sediments. So this bedrock is thrust out over the top of it. It's kind of an oblique, weird view, and there's been some collapse of the trench wall, so it's not great, but just shows you kind of what it looks like. Here's that one that I was talking about where this forest soil is on the left here, where bedrock is thrust out over the forest soil. So we were able to collect radiocarbon dates from this forest A horizon that had preserved tree branches and stuff on it with bedrock sitting right on top of it. So that's the thrusting there. Some geologists working in there. And then some really happy young interns who were pretty stoked to be in a trench, including myself and my friend Charlie Narwhal. So these are just us goofing around, looking at features in the trenches. So I just wanted to show those because we talked about the Seattle Fault, but some perspective of how kind of the mapping really played into the USGS, who we were interning for, kind of figuring out where to put the trenches and how to get information out of them. That really funneled into seismic hazards assessment for the city of Seattle, which before LiDAR, they didn't even know. They knew the Seattle Fault was there, but had no idea the active traces and where they went. So any questions or comments on these images?
They're really cool images.
It was a fun little project, and I've been in a lot of trenches all over the world, and some of the places are more exciting than others, and this was just pretty exciting because it was novel, new, first kind of LiDAR that was being used for earthquake geology. And I was just fortunate enough to be there and learn from a bunch of other senior geologists for 2 summers actually, and a couple weeks each time. So yeah, some pretty amazing features in the glacial sediments and the bedrock, and yeah, it was awesome. So just gives you a little perspective of kind of why we do the mapping. It has implications for engineering, design of facilities, and just seismic hazards in general. But it all starts with the mapping, and figuring out the uncertainties in the mapping is really important, because if you're wrong, you're going to dig a trench, you're not going to see anything, and that happens many times. So you want to really pay attention to where, you want to know where those traces are when you're doing the mapping. So a lot of question marks and a lot of dashed lines as you're mapping. You can always go to the field and kind of check them later, but what you see and interpret in the LiDAR is really important. And that's all I really have for today. So any other discussion? And hearing none, thanks everybody. And this homework assignment will be due next Wednesday. And is there anything due before Tuesday? Any reading or anything, Chelsea? I don't remember.
There's no reading.
Okay. So no questions or anything due on Tuesday?
Correct. So I think on Tuesday we'll go over the assignment, and I may send you some areas in advance and ask you to rank which faults you would be particularly interested in mapping.
Okay, good. And the DTM for this normal fault project is kind of large, so it may take a while to download. Chelsea, it took her a long time.
I think the Nevada LiDAR is throttles their downloads.
Yeah.
Uploaded it in an hour, so it should download in maybe 10 minutes or something.
Okay, cool. Yeah, so download it when you can. Just let us know if you have any problems getting the data, but it's basically just the one DTM, and you can do everything from that.
Yeah, it's on the course website now, so you should, if you can't get it, let me know.
Okay. Awesome. Well, thanks everybody.
Thank you for your time.
Thank
Good
you.
luck with normal faults. If anyone wants to hang out to learn how to export a map, I might listen in on that.
Yeah, I'll make it really fast too, so it won't take too much of your guys' time.
I'll stop sharing my screen.
If you want to share it, John, you can.